Hi.
To design any process, it is important to describe various process variables. Now, in order to describe these quantities, we will be needing to take a look into our chemistry equations and concepts. Chapter 4, Describing Physical Quantities. The contents we are going to cover are units and some important process variables. Units. All physical quantities have a numerical value and a unit. For example, a numerical value of 6.51 should indicate a unit such as in feet, grams, seconds, etc. The three kinds of measurement systems are shown here in the table: CGS, SI and American units. Conversion factors. It is the relationship between the two sides of an equation where both sides should have the same quantity but different units. Examples: 12 inch is equal to 1 feet, 1000 gram equal to 1 kg and 60 second is equal to 1 minute. Let us now do the calculation in practical. We have to draw lines according to the numbers we have, and we need to convert 28 inch to feet. So the second one is the right one, where it has to cancel each other to get 2.33 feet. Moles. Number of moles is simply mass over molar mass. Here it shows the type of moles in different measurement systems. Molecular weight. Number of mole equation is rearranged to get molecular mass is equal to number of moles over the mass. Example for oxygen is shown here in different measurement systems. The simples we use in the equation: M is the total mass, Ma is the mass of a particular material A, N is the total number of moles, and Na is the species A number of moles, and molecular weight of A is the molecular weight of species A. Let us now solve an example 4.1 where common table sugar sucrose is given with its mass in 100 lpm, and we have to calculate number of moles in kg mole and lp mole. So for the solution, we know the atomic weights of carbon, hydrogen and oxygen. Using these, we can calculate the molecular weight of sucrose. Now we convert 100 lpm mass into kg using the conversion factor, where lpm and lpm has to cancel each other to get it in kilogram. Now we can easily calculate the number of moles in kg mole and lp mole using number of mole equation. Compiled and defined units. Examples: density, velocity, acceleration, volumetric flow rate, mass flow rate and concentrations with CGS, SI and American systems are shown in the table. Force, which is equal to mass into acceleration or mass into gravity. Here in the table it shows different values for the gravity in different units. Pressure, which is equal to force by area. The commonly used units of pressure are shown in the table. Some important process variables: density, flow rate and mixture compositions. The equations are also shown here. Mass flow rate of species A, or m dot A dot, represent the flow rate of species, any species. Here shows the equations for different forms, and also the molar flow rate of species A is also shown in different ways. Conversion between mole fraction and mass fraction. How can we convert from one to another? In the first figure, it shows the strategy for converting mole fractions to mass fractions, and secondly, in the second figure, it shows for converting mass fraction to mole fractions. The steps are shown here. Let us now understand this concept through an example 4.6. This question gives mole percentages and we have to convert this into mass percentage. So that for the solution we have to assume number of moles is equal to 100 moles. Using the given mole fractions, we can find number of nitrogen in the air using the equation. Similarly, we found out the number of moles of oxygen and argon in the air using the same equation. Now we can calculate the number of grams for each substance using the molecular weight. The equation: mass of a species equal to molecular weight into number of the same species. So after calculating the mass for each species, we can sum it up to find the total mass. So mass fraction can be found using the equation: mass fraction of a species equal to mass of a species by total mass. Now we can find the mass fraction for each. Dimensional consistency, there are some rules to follow. First of all, terms that are added together must have the same units or even subtracted. For example, q equal to ab plus c2, these two ab and c2 must have the same units. Secondly, exponents must be unitless. For example, y equal to x raised to ab by c. Here the term ab over c must all cancel out to leave no units. To conclude this chapter, we can say that the units and its numerical values are very important to note. So in further study or in our next videos, we will be studying more in detail how we can implement these physical quantities in equations and everything in our next chapter, material balance.